Hey everybody, welcome back to the shop. Today, we're diving deep into the world of structural steel. Whether you're an engineering student trying to wrap your head around your coursework, a construction professional looking to brush up on your knowledge, or just a curious mind like me, understanding how we use steel to build the world around us is pretty darn fascinating. We're going to be exploring the different types of structural steel, from the common I-beam to the less obvious steel deck. We'll break down their unique properties and see how they come together in everything from skyscrapers to bridges. So, grab your hard hats and safety glasses because things are about to get structural up in here. Alright, let's talk beams. These are the workhorses of structural steel, the horizontal heroes that hold up our floors, roofs, and bridges. You've probably seen them a million times. Those big, long pieces of steel with a cross-section that looks kind of like the letter I. And that's not by accident. That shape, called an I-beam, or a W shape, is incredibly strong for its weight. Think of it like this. If you take a flat piece of steel and try to bend it, it's relatively easy to do. But if you fold that same piece of steel into an I shape, suddenly it's much more resistant to bending. That's because you've increased its what we call moment of inertia. Basically, its ability to resist bending forces. Now you've got different flavors of beams. You've got your standard W shapes, your S shapes, which are kind of like I-beams with sloped flanges, and your C shapes, which look like, you guessed it, the letter C. Each of these shapes has its own strengths and weaknesses, and engineers carefully choose the right one based on the specific loads and spans they're dealing with. For example, W shapes are great for long spans and heavy loads, which is why you often see them in bridges and large commercial buildings. S shapes are often used in situations where you need a beam to cantilever out, like a balcony, for instance. And C shapes are handy for things like purlins in roof systems. It's all about choosing the right tool for the job, and when it comes to beams, there's a whole toolbox full of options. If beams are the horizontal heroes, then columns are the vertical champions. These are the guys that take all the weight from the beams above and transfer it safely down to the foundation. They're the unsung heroes that allow us to build high into the sky. Now, you might think a column's job is pretty simple. Just stand there and take it, right? But it's a bit more complicated than that. Columns have to deal with something called buckling. Imagine trying to compress a drinking straw. Eventually, it'll buckle and collapse under the pressure. Columns can do the same thing, especially if they're long and slender. That's why engineers carefully choose the shape and size of columns based on the loads they need to carry and the height of the structure. You'll often see W shapes used for columns, just like beams, but you'll also encounter something called HSS, which stands for hollow structural sections. HSS are basically big, hollow tubes of steel. They're incredibly strong in compression because the material is distributed evenly around a central axis. Think of it like a soda can. It's much harder to crush it from the top than it is to bend it from the side. So whether it's a W shape, an HSS, or even a concrete-filled tube, columns are the unsung heroes of the structural world, silently bearing the weight of our built environment. Okay, maybe angles aren't the most glamorous members of the structural steel family, but they're the unsung heroes that hold everything together. These L-shaped pieces of steel might seem simple, but they play a vital role in countless structural connections and supports. Imagine you're building a steel frame. You've got your beams and columns in place, but how do you connect them? That's where angles come in. They're often used as cleats or brackets to connect different members together, providing additional strength and stability. One of the great things about angles is their versatility. They come in a wide range of sizes and thicknesses, so you can find the perfect angle for just about any application. Need to connect a beam to a column? Angle. Need to brace a wall stud? Angle. Need to create a support bracket for a pipe or duct? Angle. They're like the duct tape of the structural world. Not always pretty, but they get the job done. And while they might not be as flashy as a soaring beam or a towering column, angles are essential components of countless structures, working diligently behind the scenes to keep everything connected and secure. Now, let's talk about plates. Those flat, unassuming pieces of steel that often go unnoticed, yet play a critical role in structural integrity. They're kind of like the stagehands in a theatrical production. You might not see them, but the show wouldn't go on without them. Plates are used in a variety of ways in construction. One common application is as gusset plates. These are triangular or rectangular plates that are used to connect beams, columns, and braces at their joints. They provide additional surface area for welding or bolting, which increases the strength and stiffness of the connection. Another important use for plates is as stiffeners. Think about a thin-walled beam. Under heavy loads, the web, the vertical part of the eye, can buckle or distort. Stiffeners are plates that are welded or bolted to the web to prevent this from happening. They add rigidity and help the beam to carry the load more effectively. And then there are base plates. These are thick plates that are placed at the bottom of columns to distribute the load over a larger area of the foundation. They prevent the column from punching through the foundation and ensure that the weight of the structure is transferred safely to the ground. Trusses, those intricate lattices of steel that span vast distances, supporting roofs, bridges, and other structures. They're a testament to the power of triangles in engineering. You see, triangles are inherently stable shapes. They're able to distribute loads evenly throughout their members, making them incredibly efficient for spanning long distances. A truss is essentially a series of triangles connected together to form a rigid framework. The individual members of a truss are typically subjected to either tension or compression, but not bending. This allows engineers to use materials more efficiently, resulting in lighter and more economical structures. There are many different types of trusses, each optimized for specific applications. You've got your Warren trusses, your Pratt trusses, your Howe trusses, the list goes on. But they all share the same basic principle, using triangles to create a strong and lightweight structure. Think about a bridge, for example. A truss bridge can span hundreds of feet using a relatively small amount of material, thanks to the efficient load distribution of its triangular design. The same principle applies to roof trusses, which allow for large, open spaces without the need for interior columns. All right, let's talk about open web steel joists. These guys are the unsung heroes of floor and roof systems, providing lightweight yet strong support for a variety of applications. They may not have the sheer brawn of a heavy I-beam, but their strength lies in their versatility and efficiency. Imagine a grid of steel, crisscrossed with diagonal members, creating a web-like structure. That's the essence of an open web joist. This design allows for the passage of electrical wiring, plumbing, and HVAC ductwork through the open spaces, simplifying installation and reducing overall construction costs. Open web joists are typically made from hot-rolled steel bars or shapes that are welded together to form the chords, the top and bottom members, and the web members, the diagonals. The spacing and size of the members are carefully engineered to handle specific load requirements and span distances. One of the main advantages of open web joists is their lightweight nature. Compared to traditional timber or concrete framing, steel joists are significantly lighter, which reduces the overall dead load of the structure. This can lead to savings in foundation costs and allow for larger clear spans. Finally, we come to steel decking. Thin, corrugated steel sheets that might seem unassuming at first glance, but play a vital role in modern construction. They serve as a crucial component in composite floor systems and often pull double duty as structural roof decks. Picture a concrete floor slab. It needs support, right? That's where steel decking comes in. These corrugated sheets act as formwork for the poured concrete, supporting its weight until it cures and gains strength. But here's the cool part. Once the concrete hardens, the steel decking doesn't just go into retirement. It actually works together with the concrete, forming a composite system that's stronger and stiffer than either material alone. The corrugations in the steel decking create a mechanical interlock with the concrete, preventing slippage and ensuring that the two materials act as a single unit. This composite action allows for longer spans, reduced concrete thickness, and improved fire resistance. But steel decking's talents don't end there. It's also frequently used as a structural roof deck, supporting insulation, roofing membranes, and even solar panels. Its lightweight nature, combined with its strength and ease of installation, makes it a popular choice for a wide range of building applications. So, there you have it, a whirlwind tour of the world of structural steel. From the mighty beams that hold up our buildings to the humble angles that connect it all together, structural steel forms the backbone of our modern world. Understanding the different types of steel and their applications is essential for anyone involved in the design, construction, or simply appreciation of the structures we inhabit every day. If you found this deep dive into the world of structural steel as fascinating as I do, be sure to give this video a thumbs up, share it with your friends, and subscribe to the channel for more exciting explorations into the world of engineering and construction. Until next time, keep building.